Hey, so in this video we are going to be talking about matrices and simultaneous linear equation. This is just an intro and we would be discussing matrices in coming videos, and later on we would solve simultaneous equations with the help of matrices. In this video it is just a basic intro with matrices and simultaneous equations. So in last video we discussed linear equations and how you can differentiate if the given equation is linear or not. So in this video we would talk about simultaneous linear equations. As you can see here, we have three equations and each one of them has three unknowns. Now in simultaneous linear equation you would have to solve these equations simultaneously, as the name suggests. So you would not solve one equation but all three of them simultaneously. So when you are done with that, it can either have a single solution that would satisfy all three of the equations simultaneously, or it would have an infinite many solution. And in that case it would be forming a line or it would be laying straight on it. We would discuss these things in coming videos, so don't worry about this. Or it can be the third point with no solution. Basically they would be parallel to each other, which means they would never be intersecting or be laying on each other. So that's a very separate topic but is related to this. So just keep this in mind. I would definitely be making videos on these concepts. So in this video just keep your focus on simultaneous linear equation. So the upper example was with the three unknown variables. Now the second example is with the help of two variables and two equations. We have x1 and x2. In the last video we also discussed the variables can also be given a subscript. In this case x is an alphabet, so we use a single alphabet, but what we do is that we give it a subscript. This way if we have 100 for example 100 variables or 100 unknowns, we won't basically just run out of variables. So this way we can have just the x but with the subscript. This way we can have multiple unknowns. So we have one x1. I could have just written x1, but it doesn't really matter, just to give you an insight what the coefficient may look like. So 1x1 plus 2x2 is equal to 0. The second equation is 3x1 plus 4x2 is equal to 0. So again it can have either of the solution, right? Single solution, infinite many, or no solution. Coming towards matrices, what matrices are? Basically if I simply put, they are just a way to represent data in the form of rows and columns. For example, same with this earlier examples of simultaneous equation, if we try to make a matrix out of these equation, it would not just help us to compact the information but also allow us to perform different operations on them. So right now, if just to give you an idea of what a matrix is, it's basically represent data in the form of rows and columns. So the number of rows and the number of columns of a matrix are its dimension. The very first number that you are seeing under the matrix is its rows, the number of rows, and the other number is the number of columns. So how many rows there are in this matrix? For example, this is the first row, second row, and third row. Rows are horizontal, so basically three rows are there. Now let's count the columns. First column, second column, third column. There are three columns as well. So it is a 3 by 3 matrix. Remember that rows always comes first and columns comes at the second. So this matrix is a 3 by 3 matrix. Now coming towards the matrix B, how many columns and rows are there? So if I check about the rows, first row and second row, so there are two rows, So that's why 2 is written already there. And how many columns are there? So this one is the first column, second column. So these are to be called as 2 by 2 matrix. So matrix A was 3 by 3 and matrix B is a 2 by 2 matrix. Now coming towards the representation of simultaneous equations in the form of a matrix. It's a very simple thing. Just arrange the variables. For example, if I talk about x variables, arrange variables in all of the equation in single column. So x is in single column, y is in single column, and z is in single column. This way it is much more efficient. So when you would be like making a matrix out of this equation, there's a very low chance of making a mistake, because I've seen a lot of people doing this sort of silly mistake when they are transforming a system of linear equations into a matrix. They basically don't really take heed into looking where each unknown is. So what happens is, if for example if we have a y variable, currently it's in the second column. If one of the equation has the y variable or y unknown on the left side, in the position of x currently, so this can mess up the whole linear equation and the result would be quite different. Maybe there might be no solution for that equation as well. So just keep in mind, keep each of the variables in their columns. So when you are transforming the matrix into transforming a simultaneous equations into a matrix, that would be quite easy and handy. So let's see how it's going to be done. Since each of the variables is in their own columns, so we would just, if I do the same operation on this one, let's just put the brackets in. So now we don't need the variables. So if we just raise the variables, isn't it the same matrix as we have written earlier? Like 1, 2, 3, 4, 5, 6, 7, 8, 9. Same with the equation. The second equation is, if you want to make a matrix out of this, just keep all of the variables, so like different variables in this different columns. So then you would just put a bracket, or you can make like a separate matrix for this. So put the values in 1, 2, 3, 4. So this is your simultaneous equation in the form of matrices. Later on, we would be discussing how to add matrices, subtract matrices, multiply matrices, and after that we would do the Gauss-Jordan elimination. Gauss elimination, which is also known as row elimination method, and Gauss-Jordan, which is also known as reduced row echelon form. These are quite easy topics, and if you have a good grip on adding, subtracting, multiplying, and making a matrix into the reduced row echelon form or row echelon form, that would be really helpful, since the advanced topics requires you to know these sort of basics operation, and we would be discussing about these topics in the coming videos. Thank you.